Okay, today guys we're going to talk about conditional probabilities. In order to work with conditional probabilities we have to refer back to the multiplication rule that we had before. In particular we're interested in the second part of the multiplication rule that says probability of A and B equals the probability of A times the probability of B given A when A and B are dependent. Alright, again this little part here with the line says, or should be stated as the probability of B given that A has already occurred. What we'll do is we'll take that formula and we'll divide each side by the probability of A. When you do that you get the probability of A and B divided by the probability of A equals the probability of B given A. And you can see it down here in a form that's maybe a little easier to read. Again, the probability of B given A equals the probability of A and B divided by the probability of A. It's just an extension of that multiplication rule. Let's look at an example. So, suppose that a person finishes his work on a given day. The probability he finishes his work in a given day is 5/6. Let's also suppose the probability he finishes his work and cleans up his work is 3/4. Find the probability that he cleans up his work given that he finishes his work. Alright, let's write out that probability first. The probability he cleans up given that he finishes. The given part goes to the right of the vertical line. Let's also write out what we know. We know the probability he finishes is 5/6. The probability he finishes and cleans is 3/4. Knowing the conditional probability rule, we write this. The probability he cleans given that he finishes equals the probability he cleans and finishes divided by the probability he finishes. We plug in our numbers, 3/4 over 5/6, and we reduce that or simplify that to 9/10. A very simple example, a little strange example, but I'm just trying to get you to see how this formula works. Let's look at another example. Let's suppose a store sells widgets from Company A and Company B. 80% of the store's widget stock comes from Company A. 20% comes from Company B. 3% of the widgets made at Company A are defective. 2% of the widgets made from Company B are defective. If a widget is randomly selected from the store stock, what is the probability that it came from Company A given that it's defective? I should write that out. Given that it's defective. I don't think I wrote it here. But that's what we're trying to do. So if we know that a widget is defective, what is the probability it came from Company A? Using the conditional probability formula, that would be the probability of A and defective divided by the probability of defective. Now we know a lot from the problem. We know the probability that the widget came from Company A is 0.8. Probability it came from Company B is 0.2. We also know the probability it's defective given that it came from A is 0.03. Probability it's defective given it came from B is 0.02. So we're going to use all this. First of all, we're going to break this formula down a little bit. Again, using our multiplication rule that we can manipulate in a variety of ways. The probability of A and defective could be written as probability of A times probability of defective given A. Alright? Again, that's just using the multiplication rule. Probability of defective we're going to have to do a little more work on. We need to break this down into all the possible cases. Something could be defective and from A, so we write A and defective, or it could be from B and defective. In other words, the probability of defective has to be broken down into all the ways that something could be defective. We're going to break down the bottom even more. We'll leave the top as it is. the bottom will be broken down in a similar way. A in defective is probability of A times probability of defective given A. B in defective can be written as probability of B times probability of defective given B. Now let's plug in the numbers. Probability of A is 0.8. Probability of defective given A is 0.03. On the bottom, 0.8 for probability of A, 0.03 probability of defective given A. Probability of B is 0.2. Probability of defective given B is 0.02. All we need to do then is work out the top using our calculator, work out the bottom using our calculator, and we have the answer.